Hello, it's Bill again, and today we're going to do a deeper dive into entanglement. We're going to look at the computational aspects. First, I want to do a review of definitions. Cosmic event horizon is the maximum boundary for any given host particle consisting of a spherical horizon that behaves much like an inverted universe-sized black hole relative only to the host. Cosmic horizons cause the emergence of dark energy, which appears to redshift objects out of a given host particle's observable universe. Cosmic event horizons are the engines that process information and redistribute entropy from local to cosmic scales. A host particle is a fundamental particle at the center of its own cosmic horizon, which defines the limits of its observable universe. A host particle cannot cross its own cosmic horizon, although the horizon size dynamically evolves. A host particle has a universe worth of information associated with it, 10 to the 122 degrees of freedom, in the form of horizon Planck areas, Hawking photons, and other guest particles. A host space is the unique relative space between a host and a host cosmic event horizon. A guest particle is any particle within a host particle's observable universe that is not the host itself. Guest particles interact dynamically with host horizons and can appear to exit the host universe via cosmic horizon redshifting. Guest particles have 1 degree of freedom. So here we have a diagram showing how particle information is encoded. And what we have here is this is host A's observable universe. And this is going to be host A's spin right here that's projected on its cosmic horizon, projecting the particle into space. And it's at 10 to the 122 Planck areas of resolving power here. So it can resolve any entanglements it comes across using that energy. Now here we have guest B, which is a guest in host A's observable universe. Now it's a host in its own right, but for host A, it's a guest. And it's a 1-bit data replica of spin holographically encoded on A's horizon. C here is shown in orange, and it's as well encoded as a 1-bit data replica on host A's cosmic horizon. And D as well, as you can see in the purple. Stage 0, particles in superposition, no association energy present, i.e. no entanglement. So here I have host A's cosmic horizon. Remember though, it's a sphere, but we're just taking a piece here. And we have B using host B's cosmic horizon. And you can see we have host A information that's holographically encoded, so it's everywhere. I use 3 labels to show that. Guest B is everywhere across the entire horizon, but I just use 3 labels. Now over here we have guest A because A is a host here, but is actually a guest here. These particles have not addressed, they're only addressed to the cosmic horizon, so they're not addressed with each other at this point in time. Stage 1, 2-bit addressing across cosmic horizons. Host A and B interact and now share an entanglement boson on each of their cosmic holographic horizons. This boson associates the host and guest particle information across both horizons as a 2-bit system. So finally, A and B bump into each other, and because they did not have spin sign, they're entangled. And they're addressed as 2 bits. Here you see on host A's cosmic horizon, host A and guest B is 2 bits. Over on B's horizon, you have host B and guest A, 2 bits. And this is the quantum uncertainty, because we could either have up, down, or down, up, and that's 2 bits of information. Stage 2, spin injection and quantum to classical conversion. So host A and B are entangled. Particle C arrives and imparts spin to A. The first particle measured is the one whose cosmic holographic horizon will resolve the spin and manage the associated entropy cost. So here C comes in and bumps into A, and C was down. So what happens is C is going to translate up to A. So host A and guest B were 2 bits. This is the process of condensing the 2 bits down to 1. Host A is going to transfer its spin energy to guest B. It's important to notice that guest B and host A will share the same spin sign because they're on the same horizon. Stage 3, classical bit emerges, gravity emitted. Host A translated its spin to guest B. Now that A is no longer entangled with B, the quantum uncertainty of 2 bits becomes 1 classical bit. Guest B will reflect the same spin sign energy as A. Now, this part here, the quantum uncertainty of 2 bits becomes 1 classical bit. And how that happens is erasure. A Planck area erasure severs the entanglement from A to its host horizon, and that causes gravity to snap back to A. Guest B is now an observer particle, and you can see it has the same sign as host A. So guest B becomes an observer particle and may now resolve its spin energy onward. This erasure breaks A's entanglement. So A can actually entangle again from this point. And you can see that A has kind of lost its juice there by putting gravity back at particle or host A there. Stage 4, closing the books with Hawking photon emission. Guest B locks spin into host B when host B interacts with a new entangled pair, or it could be a new particle. It translates the spin, continuing the cycle. This interaction triggers the Hawking photon emission from host A, completing the energy ledger. Guest B's constraint acts like a capacitor, releasing the leftover information as a spin-locked Hawking boson. Here's where the sign changes, because now it's gone from A's cosmic horizon to B's cosmic horizon, and from perspective, B will see the opposite sign. When host B interacts with entangled pair DE, guest B potentiates the Hawking photon by drawing a tiny portion of the interaction energy from interacting with D. This energy is emitted into host A's observable universe as a photon, conserving energy and entropy. Now here we have a spin equation, and what this is S plus and S minus are spin. S plus is the determinate spin, so A is the first particle to be measured, is labeled A. So this is the determinate spin. This is the negative energy, gravity, that translates the spin from host A to guest B. And then for B, you get the subordinate spin. It's going to be opposite of this. And then you get the Hawking photon emission, and everything conserves. And we're back to stage 0. Returning to superposition, the cycle is ready to begin again. Host A and B are both back in superposition with each other or with new particles. All information has been fully expressed and translated. The total cost of the cycle, 1 unit of cosmic horizon gravity via a Planck area erasure, and 1 unit Hawking information. And once again, now host A and guest B are unassociated. Thanks for watching this video. We have a playlist that's really good as well. You can learn a lot, beginning with the gravity presentation. And just keep thinking and keep exploring, and we'll see you later. Have a great day.